Hey, my name is Matthew. Today we're going to be doing a little bit of mathematical statistics. We're going to cover doing PDF transformations using the CDF method. So, given a continuous random variable x with a PDF that we know called f sub x, and another random variable y, which is some function of x, where the function is invertible so that the inverse exists, we want to find the probability distribution function of y. So we're going to need to use two facts. First of all, the cumulative distribution function of a random variable is given by the probability that that variable is observed to be less than a given value. So we're also going to need the fact that the PDF is related to the CDF by the derivative. Alright, so just to show you how the transformation works, if you start with the CDF of y, that's the f sub y is the cumulative distribution function of y. That's by definition the probability that the random variable y is observed to be less than or equal to the given value y. Going from that probability, we substitute in the fact that y equals u of x, and we say that this is the same as the probability that u of x is less than or equal to y. This in turn we can solve by multiplying both sides by the inverse of u, since we've guaranteed that the inverse exists. So we end up with the probability that x, the random variable, is less than or equal to u inverse of y. Now this it should look familiar. It's of the same form as this here, with the probability of a random variable less than or equal to a value. But in this case, the random variable is x. So this is the cumulative distribution function of x at the value u inverse of y. So going from the top down to the bottom, following the logic, we have that the cumulative distribution function of y is equal to the cumulative distribution function of x evaluated at u inverse of y. Alright, so we're going to be using this, which is what we just showed to be true. We want to find the PDF of y using the relationship that the PDF of y is equal to the derivative with respect to y of the cumulative distribution function. Alright, so replacing fy with fx, we get this. Okay, and we're going to differentiate this. So because the derivative of f sub x is little fx, we can just do that, but we also need to use the chain rule. So we need the derivative of u inverse of y. Now, the reason why we're taking the absolute value here is because we want the positive value here. If u is an increasing function, this is going to be positive anyways, and if u is a decreasing function, then this will actually be negative, and we need it to be positive, so we take the absolute value. We now have a formula for the distribution of y given the distribution of x, so long as we know the inverse of our transformation and the derivative of the inverse. Alright, so now we're going to look at an example of how to use this. So suppose that you have a random variable x with a PDF f of x such as this. we want to find the PDF of y, which is this function of x. So the things that we have available to us, f sub x is x cubed. Our y is a function of x, which is log of x plus 3. And solving this equation for x, we have x is equal to u inverse of y is equal to e to the y minus 3. You see we're just exponentiating both sides and then subtracting 3. Alright, and we want to find the derivative of u inverse. That's just the derivative of this right here. So we have derivative of e to the y minus 3. The 3 is just a constant, so the derivative will get rid of that. So we end up with just e to the y. Okay, now we want to plug that into the formula that we found, which is right here. We have our f sub x, which is the cubed function, so we got the cube right here. We have our u inverse of y, which is e to the y minus 3. And we have the absolute value of the derivative, which is the absolute value of e to the y. Now, e to the y is always positive, so we actually don't need these absolute value signs here. Alright, but we're not done. We also need to find the domain for the PDF of y. And since we know from the outset of the problem that x is between 0 and root 2, and we have our function of x here, we can go from x is between 0 and root 2, and we want to change this into this function here so we can replace it with y. So if we add 3 to both sides, we get 3 plus root 2, 3. Okay, then we want to take the log, so we have log 3, log of x plus 3, log of 3 plus root 2. Now this here is just y because of this up here. So we have that y is between log 3 and log of 3 plus root 2. Alright, we have found the PDF of y. It's given as such. So that's just one simple example of what you can do with the CDF method. It's very useful for finding probability distributions for functions of known distributions, or functions of random variables with distributions that you already know. Alright, thank you guys for watching. I hope you found this useful, and I'll see you guys next time.